Today we're going to be having a look at this, which is a partial revisit of our Classic II RC2014 computer. This is a Z80 retro computer. Which, as you can see here, we have the backplane mounted in a maker beam frame for convenience. This gives us 8 slots we can actually occupy with our different Z80 cards. So we're going to have a look at each of the cards we're going to be fitting into this rack. First of all, we have one of these. This is our clock and reset card, which has the quartz clock and our reset button. The second module is this. This is the serial I/O. This allows us to connect a cable to our main computer so we can communicate with it. It also has a little plug header on the board to allow you to power the entire computer from this serial cable. We will be powering our computer from the barrel jack on the backplane. The third module we're going to look at is the ROM module. This is a Classic II banked ROM. This will allow us to either use Basic or the small computer monitor. The next module is one of these. This is a RAM board. However, this is non-volatile RAM. Ferroelectric random access memory, known as either FERAM or FRAM, is a high-performance, non-volatile memory. Providing the benefits of both dynamic RAM and ROM, this type of memory consumes less power, is many times faster, and can handle a very large number of write cycles without degradation in comparison to NAND technology. Having a lower power consumption than NAND when writing, it is ideal where fast write speed and battery-powered systems are required. Like NAND chips, FRAM is non-volatile, allowing these Z80 systems to retain that key data in memory for years at a time. This will allow our basic programs to reside in memory even when a computer is switched off. And next, we have our CPU module. This is not an original CPU module for the Classic II. This is a replacement as I had problems with the other board. And the final module we'll be adding today is this. This is a 7-segment display. This allows 4 separate digits to be displayed at the top of the board. And we're going to be programming this in BASIC to display prime numbers. So let's assemble our computer. First of all, we will put in our clock and reset module. Next, we will add in the serial I/O module. Now, the ROM module. And next, we're going to put in the non-volatile RAM. And now we have the CPU module itself. And the final module is our LED display. And that completes all the modules in our computer. And we still have 2 slots free at the front, which we can use for other modules. So to communicate with the main computer, we're going to use a USB serial cable. One of these. I'm going to make sure it's the correct orientation. And that's it plugged in. And we have the USB end of the cable, which we will plug into our main computer. So we will set this up and we will install a basic program to run and calculate prime numbers. Now we're ready to try out our Z80 retro computer. So first of all, we will attach the battery. As you will see, the power light has now come on. So we next need to launch Term to allow us to communicate with the computer. So we will set our serial port to COM5. And we can now hit the reset button on the RC2014. On the screen, it comes up cold or warm start. I have previously loaded a basic program into the non-volatile memory. So if we do W for a warm start, this should still be in memory. Now we have entered into the basic language. If we key list, it lists the program which is already stored in the memory. As this is non-volatile memory, this saves you having to reload programs every time you power the unit up. If we now run our application, it will attempt to generate prime numbers. As you can see on screen, it's displaying each prime number as it is detected, and on our 7-segment display, the prime number is also shown. Obviously, the RC2014 computer is not as fast as your normal desktop computers. However, this doesn't mean it can't be used for some interesting little projects. So let's reboot the machine once more and do a cold start. As you will see now, there is nothing in the memory. All we need to do to copy our program from this notepad file into our Z80 computer is to copy the whole text, Ctrl-C for copy, and then once back in Term, if you right-click, it will pop up the clipboard information. We can then hit OK, and it will write all of this into your memory. And there is your program. So to prove it's actually gone into the non-volatile memory, let's reset the computer once more. If we do a warm start, and a list, and there is your program. The non-volatile memory card comes in a 32 kilobyte size. While 32 kilobytes is only half of what the Z80 can address, 32 kilobytes is very useful. It would be ideal if the manufacturer of this board would bring out a 64 kilobyte version. But in the meantime, I can still make great use of 32 kilobytes. And the 7-segment display is useful for these kinds of purposes, for counting anything up to 9,999. I'll put the code for this particular application on the GSF software website. However, that's it for today. Thank you for watching.